In this video, we're going to explore the concept of how to scale up ratios. Scaling up ratios is essentially the reverse process of simplifying them. If you're unsure about how to simplify ratios, it might be a good idea to review our earlier video on that topic first. To quickly recap, if we have a ratio like 6 to 9, which might represent something like blue cubes to red cubes, then to simplify it, we look for the largest common factor shared by 6 and 9, which is 3. We then divide both numbers by this factor. So we do 6 divided by 3, which gives us 2, and 9 divided by 3, which gives us 3. Therefore, the simplified version of the ratio is 2 to 3. Now, when we scale up ratios, we are doing the exact opposite. Instead of simplifying, we take a simpler ratio, such as 2 to 3, and we multiply both parts by the same number to generate an equivalent but larger ratio, like 6 to 9. For instance, we could scale 2 to 3 up to 20 to 30 by multiplying both sides by 10. Similarly, we could scale it up to 300 to 450 by multiplying both sides by 150. The critical point to keep in mind is that all of these scaled ratios are considered equivalent. This means that 20 to 30, 2 to 3, and 300 to 450 all express the same proportional relationship. In exams, a common question format involves providing you with only one of the scaled-up quantities and asking you to determine the other. For example, suppose we are told that a pile of cubes consists of blue and red cubes in the ratio of 2 to 3. If we are told that there are 10 blue cubes, we need to determine how many red cubes there must be. To solve this, we start with the original ratio of 2 to 3 and place the number 10 beneath the 2, since that represents the number of blue cubes. Next, we ask what we need to multiply 2 by to get to 10, which is 5, and then we multiply the 3 by 5 as well, resulting in 15 red cubes. Let's consider another example with a slightly different ratio. Suppose the cubes are in a ratio of 4 to 7, and we are told that there are 56 red cubes. We are asked to find out how many blue cubes there are. We begin by writing the ratio 4 to 7 and placing 56 under the 7, as red cubes are represented by the second number in the ratio. We then determine what 7 has been multiplied by to result in 56, which is 8, and thus we also multiply 4 by 8, yielding 32 blue cubes. Another common type of question asks for the total number of items when one part of the ratio is known. For instance, if we know that there are 24 blue cubes, how many cubes are there in total? To solve this, we use a two-step approach. First, we determine the number of red cubes, and second, we add the two quantities together. Starting with the ratio of 4 to 7, we place 24 under the 4, which stands for blue cubes. We then ask what 4 has been multiplied by to give 24, which is 6. We multiply 7 by 6 as well to get 42 red cubes. Adding 24 and 42 gives us a total of 66 cubes. Before wrapping up, let's look at a slightly more complex example involving 3 quantities. Suppose Jennifer is following a smoothie recipe that calls for 14 blueberries, 2 bananas, and 3 apples. If she wants to use 6 bananas instead of 2, how many blueberries and apples should she use? This scenario is different because it involves 3 items, but the method remains the same. First, we write out the ingredients and their original amounts, giving us a ratio of 14 to 2 to 3 for blueberries, bananas, and apples respectively. Since she wants to use 6 bananas, we place a 6 beneath the 2. We then find what 2 must be multiplied by to make 6, which is 3. This tells us that we need to multiply all parts of the ratio by 3. Therefore, 14 times 3 gives 42 blueberries, and 3 times 3 gives 9 apples. An alternative way to understand this is that Jennifer is making 3 times the original amount of smoothie, so she needs 3 times as much of each ingredient. That's everything for this video. We hope you found it helpful. If you did, please consider sharing it with your friends and teachers, and thank you for watching.